Uranium extraction and enrichment process. Uranium extraction. Uranium ore is extracted using a drill that pulls a reamer up through a pilot hole, widening it. The broken ore falls into an extraction chamber. A remotely operated bulldozer collects the uranium rock to ensure operator safety from falling hazards. Processing and centrifuge enrichment. The uranium is condensed, ground, and placed into a centrifuge for enrichment. Centrifuge enrichment works as follows. Natural uranium contains only 0.7% uranium-235, with the rest being uranium-238. Low-enriched uranium, 5% uranium-235, is used in commercial nuclear reactors. Weapons-grade uranium, over 90% uranium-235, is obtained by further enrichment. The centrifuge consists of a high-grade tube with a spinning motor at the bottom and a feeding tube at the top. Uranium hexafluoride gas is introduced into the centrifuge. Centrifugal force separates the heavier uranium-238 green from the lighter uranium-235 blue, with uranium-235 collecting at the top. Nuclear bomb designs. Little Boy and Fat Man. Little Boy, uranium bomb, uses a gun-type design, firing one subcritical mass of uranium into another to achieve a supercritical state. Dimensions. Length, 10 feet, 3 meters. Diameter, 28 in, 71 centimeters. Uranium core weight, 145.5 pounds, 65.5 kilograms. Mechanism. Electric gun primers initiate the reaction. A cordite charge propels the uranium projectile down a smooth-bore gun barrel. The projectile, 84 pounds uranium-235, collides with the target, 56.2 pounds uranium-235. Polonium initiators ensure the nuclear chain reaction. Fusing system. Barometric sensors measure altitude. Radar altimeters detect final altitude. Once the target height, 580 meters or 1,900 feet, is reached, the firing switch activates. The explosion results in a chain reaction with a devastating blast radius. Fat Man plutonium bomb uses an implosion-type design, compressing plutonium-239 into a supercritical state. Dimensions. Length, 10 feet, 3.3 meters. Diameter, 60 in, 1.5 meters. Implosion mechanism. Shaped charges create a concave shockwave inward. The plutonium core is compressed by uranium-238. A polonium-beryllium initiator triggers the chain reaction. Development. Based on the Trinity test, first nuclear explosion. Inspired by James Tuck's shaped charge concept, later refined by John von Neumann. Engineering and detonation process. Pre-launch sequence. Before dropping the bomb, 3 arming plugs are removed by the weaponeer William Sterling Deke Parsons. Bomb deployment and activation. The bomb falls from the aircraft and switches to an internal 24-volt battery. After 15 seconds, it reaches approximately 3,600 feet, 1,100 meters, from the aircraft. The barometric sensor detects the preset detonation altitude, 1,900 feet or 580 meters. Radar altimeters confirm the final altitude for detonation. Firing mechanism. The firing switch activates the 3 Navy gun primers. Cordite charges ignite, launching the uranium projectile at 300 meters per second. Polonium initiators trigger nuclear fission. A chain reaction releases immense energy, creating an explosion. Nuclear explosion effects. Blast and destruction zones. Central blast zone, 0.36 square kilometers, fireball radius, complete destruction. Severe damage zone, 4.5 square kilometers, high casualties, structural devastation. Moderate damage zone, 8.7 square kilometers, significant building damage and radiation burns. Light damage zone, 11 square kilometers, fires, radiation exposure, psychological trauma. Chain reaction explained. A neutron collides with a uranium nucleus, causing fission. Each fission releases 2 or 3 neutrons, sustaining the reaction. The explosion happens within milliseconds.